So from this video I'm going to describe the code that I wrote to classify mnist dataset using CNN, convolutional neural network. So the first thing that I have to do is there are a few important libraries that I will be using in my code, so I have to import them. So I have loaded them from Keras. I will be using Keras in my code, and up next I have load my dataset. So this mnist dataset contains a set of images that has 0 to 9 digits on them, and here I have initialized my test data and my training dataset like this. So up next what I have done is I have used this reshape method in order to convert my dataset into set of matrix. So my matrix height and width is 28. It's a 28 by 28 matrix, and from 1 here I have given the channel. So it's 1 here because in my dataset it's all the images are black and white. So if I'm using a RGB set of data, I will have to use 3 instead, 1 here, and that is how I have reshaped my dataset. And before feeding my data into the algorithm in this pre-processing stage, I have normalized my data like this, and also I have used this. So here I have class 10 because I need to have an output of 10 classes because there are 10 digits 0 to 9, and in using this numpy array I have and numpy utilities, I have used this to categorical method to make my data convert into categorical set of data of my matrices like this. So we are done with our pre-processing, and up next is the most important thing, and I have used these sequential models in order to build the linear stack of layers. So this is how I have created my model, sequential model, and layers are convolutional layers inside this model. So the first that I will be creating is convolutional layer. I have used this cont2d in order to create my first layer. So from this 25, it represents the number of layers I will have in this first convolutional layer, and this is the size. It's a 3 by 3 matrix, and as my activation function I will be using relu. So this relu is specified because it converts our negative values, negative inputs into 0. For an example, if you have 5 as your input, it won't make any change to that. It will remain as 5. But if you have -1 in your dataset as an input, this relu activation function will convert it into 0. And since this is the first layer, we have to matrix shape is 28 by 28, and I have also given the channel as 1. So because Keras requires it in this format, so we have to give it like that. So in my architecture, the next layer I have is this pooling layer. So I'm using max pooling because it uses a maximum size in one block, and the size of my second layer is 1 by 1. So I have initialized that like this, and up next the third layer of my architecture is this flattened architecture. What it does is it will convert all our data, all our matrix into a single vector. As you can see, it has converted that into an object like this, 784. After that layer, so because of using this flattened layer, we will be getting a fully connected network after this. So as my last two layers, I will be using this dense function in order to create my fully connected network. For this, the layer before the last layer, also I have used this ReLU as an activation function. And this is my output layer, the last layer. So since I need to have an output with 10 nodes, I have given 10 as the number of nodes here, and for that also I will have used tens. And as the activation function, I have used softmax here, because as this 10 nodes, we will be needing the probabilities of digits. Like for 0, we need the probability of getting 0, probability of having 0. So I have used this softmax. So this is my basic architecture of the layers inside this sequential model. Now I have used and I have asked to print the summary of my model, so that I can compare, I can check the input and output sizes of my layers. So these are the output shapes, and in this third layer you can see it is a somewhat big number, because it contains all the values in the matrices, and it's a single vector. It has converted this into a single vector by using this flatten layer method. And in here, as the output, we have 10 nodes after this output layer. So the next thing we have to do is we have to compile our model. So I have parsed few parameters here. I have parsed as the loss function. I have parsed categorical cross entropy. So this loss function calculates the error of our prediction, value of our predictions, and this optimizer, it actually learns the weights. And for this instance, I have used my optimizer, Adam, as my optimizer, and I have, since we need to check the accuracy, I have passed that as well. So this is how we can compile our model. And the next thing is training the model. I have used this fit function in order to train my model, and I have passed my training data into this fit model, and initialized my batch size as 128, and also I have given the number of iterations here. So in order to get better results, we can increase this number. And also, after you execute this code, these 2 lines of code, you can see this gives us an output, and you can check if this loss function start to be similar, giving a similar value. You can stop then, because it has trained well. And then I have evaluated by giving this test data, and it has give the loss like this, and the accuracy value like this. That's it for my classification of my mnist dataset. Thank you.